Good morning, this is Kasturi Day. Today I am going to discuss the dispersion of white light through a prism. Okay. In my last video, I discussed about the diffraction of light through an equilateral prism, and then I discussed prism and also refraction of light through a rectangular glass block. Okay. So now I'm starting with this dispersion of white light through a prism. See, we know there's a well-known scientist. There was a well-known scientist, Sir Isaac Newton. Okay, so he did an experiment with the sunlight and a prism. He took an equilateral prism, and he kept that prism in a dark room with a window where there was a small hole. Okay, and he allowed the sunlight to enter from that hole into that dark room and pass through that equilateral prism. Okay, now the light which emerged from the prism was allowed to fall on a white screen. He allowed this white light, after passing through the prism, to fall on a white screen. Okay, and he found that the light which he received on the white screen was a band of 7 colors. Okay, the 7 colors were in the order from below to up. It is violet, indigo, blue, green, yellow, orange, and red. That is VIII, we call it. Therefore, the phenomena due to which white light splits were into its constituent colors, that is VIII, when passed through an equilateral prism, that is known as dispersion. Okay, and this band of the 7 colors, that is these VIII colors, that is violet, indigo, blue, green, yellow, orange, and red, which you obtained on the white screen after white light split into these colors, is known as spectrum. Okay. Now, how this dispersion occurred? Okay, so excuse me, the angle of deviation produced in the colored light depends upon its wavelength. That is, the less the wavelength, the more is the angle of deviation, and vice versa. Okay, therefore, if white light, which consisted of 7 colors, the violet color has the least wavelength and red color has the maximum wavelength. And therefore, what happens, as the violet has least wavelength, therefore it deviated the most. And as this red color has maximum wavelength, therefore it deviated the least. Okay, so different colors in white light deviate through different angles. They have different angle of deviation, such that the red color deviates the least and the violet color is the maximum. Okay, therefore the light when it is passing from the first face of the prism, when it is split up into colors, and therefore gets dispersed, while passing out from the opposite face of the prism, the various colors refract further. Okay, and therefore separate out further. See, these deviation and the wavelength, that depends on the speed of the light. Okay, the speed of the light of different colors have in a given medium, in a given transparent medium, that is different. Okay, but in air or vacuum, the speed of light of all the colors are same. Okay, so if a particular transparent medium is given, the speed of light of a colored light, that is for a given transparent medium, that for the colored light, 2 different colors of light, they have different speeds. But we will see that the violet colored light has the minimum speed and red light has the maximum speed. Okay, in a given transparent medium. Now we come to some spherical mirrors. What are spherical mirrors? Spherical mirrors are a part of a glass sphere. Okay, if we cut a part of a glass sphere, if we cut a part of the glass sphere, that becomes a spherical mirror if whose inner side or outer side is polished, and the opposite side, that is, if the inner side is polished, the outer side is non-reflecting. If the outer side is polished, then the inner side is non-reflecting. The vice versa, that is. Most of them are spherical mirrors. These curved mirrors are generally spherical mirrors, and there are two kinds, that is concave and convex. Okay. See, from the picture you can see this is the part of a spherical mirror. Concave mirror, the inner side has polished surface and outer side is non-reflecting, whereas in convex mirror, outer side is polished surface, inner side is non-reflecting. Then we come to difference between concave mirror and convex mirror. Concave mirrors are spherical mirrors whose reflecting surface is curved inwards. I told you. Convex mirror is spherical mirrors whose reflecting surface is curved outwards. A parallel beam of light falling on this mirror converge at a point after refraction. Okay, this happens in case of concave mirror. But in case of convex mirror, a parallel beam of light falling on this mirror appear to diverge from a point after refraction. What happens? This in concave mirror, the light rays after falling on the concave mirror, they come and almost join on the principal axis. I'll show you the picture how that does. And in convex mirror, if we produce as the outer surface, the bulging surface is convex, that is outer surface is convex, therefore when they strike, they appear to come from a particular point. It happens like that. Okay, now also the concave mirror are also called converging mirror, whereas convex mirror appear also called diverging mirror. Concave mirror give a real focus, is a real focus. Convex mirror has a virtual focus. Now, concave mirror used as reflectors in projectors, lighthouses, headlights, searchlights. There's lighthouse headlights, this searchlights, etc. Whereas in convex mirror, used as rear view mirrors in cars, motorcycles, optical instruments, calling bells, etc. In concave mirror, image may be diminished, same sized or magnified, whereas convex mirror image is always diminished. Okay. See, from the picture you can see that in concave mirror, the lines which are parallel to each other, these are coming as incident ray on the mirror. They, after refraction, they join at a point known as F, that is focus, that is, they converge at a point. In convex mirror, the lines which are parallel, they are incident ray on the mirror, and then they appear to diverge from a point, that is F, principal axis. On the principal axis, focus on the principal axis appear to be coming from that point. Okay. Next, we come to some terms which are related to this spherical mirrors. Okay. Then first we come to pole. It is the geometric center of the spherical surface of a mirror. See, this is the pole. P is written on the picture. So it's a geometric center of the spherical surface of the mirror. It is the midpoint of the aperture of the mirror. Okay, aperture of the mirror, that is the surface which is open, that is aperture. It's the midpoint of the mirror, you can say. Then it is denoted by capital P. Now the center of curvature, center of the sphere of which the mirror is a part, is represented by capital C. Okay, it's the center of the sphere, C. Then normal at any point of the mirror passes through the center of the curvature. If we draw a normal that passes through the center of the curvature, that is the line joining the center of curvature to any point of the mirror, is the normal on the mirror at that point. Okay. Then we of curvature. What is radius of curvature? The radius of curvature of the sphere of which the mirror is a part. Okay, it is the distance of the center of curvature, that is C, from any point of the sphere of the mirror, that is from P to C, that is the radius of curvature, represented by capital R. See, it's mentioned radius of curvature. Okay, that is from P to C, pole to C, that is center of curvature. Then we come to principal axis. Okay, now principal axis, it is the straight line which is joining the pole of the mirror to the center of curvature. It may extend on either side of the pole, represented by PC. Okay, the principal axis, that is PC, or you can say the XY, it's the part of the sphere, but PC is the principal axis. It's a straight line which joins the pole of the mirror to the center of curvature. Okay, it's on either side of the mirror. So this is today's video for today. Please go through this. If you have any doubt, please do let me know and write in the comment box. Any other questions regarding this chapter, you can also write. Okay, hope you are liking the videos. Press the like button, share with your friends, and also if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Another thing is that I'll be coming very soon, launching a website which will contain many more information regarding many more subjects, even the general knowledge also. Okay. And one more thing, if you want any other subjects to be taught on these YouTube videos, please let me know so that I can make some more videos for you that can help you in your studies. Okay. So thank you for today.